The weight of an object on Earth's moon is 16.6% of its weight on Earth. The weight of an object on Mars is a little more than twice as much as its weight on Earth's moon. Write a composite function for the weight of an object on Mars in terms of its weight on Earth. Okay, so let's just go step by step and just figure out what information they're telling us. So first, the weight of an object on Earth's moon is 16.6% of its weight on Earth. Well, that relationship basically to me means 16.6% of something. That's just going to be the decimal form multiplied by the weight on Earth. So the decimal form would be 166 thousandths, just the percentage with the decimal moved over to the left twice, and then times x, where x is the weight on Earth. That's going to equal the weight of an object on Earth's moon. We'll just call that f of x. And next, the weight of an object on Mars. So we can call that one g of y. We'll just use a different variable here. Is a little more than twice as much as its weight on Earth. So twice as much, well, that's going to be 2 times whatever the weight on Earth's moon is. So 2 times y, with y again being the weight on Earth's moon. So now we need to write a composite function for the weight of an object on Mars in terms of its weight on Earth. So we need to find the function should be g of something because we are looking for the weight of Mars, but we need to include the weight on Earth's moon, which we have as y in our g of y function. And then notice that that f of x is also the weight on Earth's moon. So we're basically just going to take our f of x equation, so 166 thousandths x, and we can just plug that right into y. And that will give us our new function in terms of x, where it's the weight on Earth. Okay, so let's just copy down again our g of y function here. And so then again, just instead of y, we're instead going to do f of x, so that we can get it in terms of x. And then we have 2, and then instead of going to put our f of x function, so 166 thousandths x. And I just highlight those so that's really clear. We're just taking one thing and substituting the other. And so this is a composition. And so we can go ahead and put that in composition notation by writing it like so, g composed of f of x, and then equals, and then simplifying this, 2 times 166 thousandths x is just 332 thousandths x. So that will be our final answer. And that is finding the weight of an object on Mars in terms of x, which is the weight on Earth. So our final answer will be the weight on the moon is f of x equals 166 thousandths x, where the weight on the moon is f of x equals 166 thousandths x, where x is the weight of the object on Earth. The weight on Mars is g of y equals 2y, where y is the weight of the object on the moon. The weight on Mars can be written in terms of the weight on the Earth as g of f of x equals 2 times 166 thousandths x equals 332 thousandths x. G of f of x can be written as g composed of f of x.